Hello, third grade. We are still working with arrays. What you need to do before we start this lesson is you need your Envision math book. And we are going to be on page 21. I'm going to show you that here. We're going to be on page 21. So go ahead and pause this video if you have to. Get your Envision math book and turn to page 21. All right, you should be back by now with your math book. And we are going to do this guided practice together. And then you are going to do this independent practice. So we're going to do the guided practice. Then you are going to do this independent practice. And then I have an exit ticket for you to do in Schoology. So our guided practice today, it wants us to focus on the vocabulary that goes along with arrays. So basically, what is an array? Remember, our big question here, which was on page 20, was how does an array show multiplication? Now, our first guided practice question says, look on page 20 and tell us, says right here, it says, tell us, what does the first factor tell you about an array? So let's look at that again and discuss it. What does the first factor tell us about an array? So in this array, Dana has 4 rows of 5 metals. And she went ahead and used counters to model her math, and she made 4 rows. It shows you right here, 4 rows. 1, 2, 3, 4. And 5 columns. That means that there are 5 in each row. If there are 5 columns, 1, 2, 3, 4, 5, that means there are 5 in each row. And so in this model, they made a repeated addition sentence telling us, hey, we could also use multiplication to solve this problem. But they solved the problem using repeated addition first. So 4 rows of 5 is the same as saying 4 groups of 5. So they went and added 4 groups of 5 together and got 20. 5 plus 5 plus 5 plus 5 equals 20. 4 groups of 5 there. And then they also wanted to show skip counting. Said, oh, you can use skip counting to find the answer to this. 5, 10, 15, 20. Pay attention to that because you're going to have to do that today too. Then they also showed us how to turn it into a multiplication equation. So it tells you right here, oh, this is what we were looking for. So the first factor, this is the first factor in this multiplication equation, 4 times 5 equals 20. And the first factor tells you the number of rows. The second factor tells you the number in each row. Let's go answer that question now. So look at page 20, which we did. What does the first factor tell you about the array? The first factor tells us the number of rows. So we're going to go ahead and write that. Number of rows. The number of rows. That's our equal groups. The first factor tells us how many equal groups do we have. In that case, we had 4. Let's do number 2. Mia puts muffins in 4 rows with 7 muffins in each row. I'm going to underline 4 rows here with 7 in each row. It says draw an array to find the total number of muffins. You're going to draw an array. I'm going to use my stamper up here. You can use circles to draw your array. And we want this to be nice and neat. So the first thing we want to do is to identify our rows. So I'm going to make a column here that's going to show 4 rows. 1, 2, 3, 4. That's the start of my rows. Remember, columns go up and down. Rows go straight across. But to start my rows, I need to make that first column, okay? So now I know I have my rows here. 1, 2, 3, 4. I have 4 rows ready to go. I need to put 7 in each row. So I'm going to start with this one's number 1, so that's 2, 3, 4, 5, 6, 7. That's 7 there. And I need to repeat that and make them equal all the way down. Remember, I have 4 rows of 7. I'm going to try to line it up the best I can. 4 rows of 7. Four rows of 7. Now, it says draw an array to find the total number. Oh, I have to find the total number. So what is this all together? I have to think about my strategy posters. I know how to solve problems like this with repeated addition. We can use repeated addition. Let's go ahead and get my marker here. So I know I have 7 here, 7 here, 7 here, and 7 here. So my repeated addition sentence would be 7 plus 7 plus 7. That's only 3 groups of 7. I need 4. There's my 7 rows. 4 rows of 7. So now I can add them together using repeated addition. I know that 7 plus 7 is 14. So I have 14 over here. And I also know I have 14 over here because 7 plus 7 over here is also 14. So if I put 14 and 14 together, I would get 28. I could double check that. 7, 14, right? And there's 14 here. So I could start here and say 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. You always want to check your answers. It's always wise to check your answers. So I received the total number of muffins is 28. I could have also turned that into a multiplication equation. So I have 1, 2, 3, 4 groups or 4 rows of, how many is in each row? 7. And that also equals 28. I added that in there because that's what we're going to have to do here in a second. So in number 3 and 4, it says write a multiplication equation for each array. Boy, all you have to do is find that first factor. Finding that first factor is easy. You have to think, how many rows do I have? How many rows? Let's count our rows. 1, 2, 3 rows. I know that's my first factor. I'm going to go ahead and put that down. Then I know I'm making a multiplication equation, so I'm going to add that operation symbol right there. We say times. So 3 times what? 3 rows of what? How many is in each row? Let's count my columns. 1, 2, 3, 4, 5. I have 5 in each row because I had 5 columns. That means 3 times 5 is what? I have 3 rows of 5. I can count by 5s to find that out. 5, 10, 15. 15. Let's do number 4 together. What's the first thing I do? When I'm looking at an array, I need to identify my rows. That's my first factor. That's why they asked that question up here. What's the first factor tell you? The first factor tells us the number of groups we have, the rows, the number of rows we have. Let's count my rows. 1, 2, 3, 4 rows. That's my first factor. 4 rows of what? How many is in each row? Let's count the columns. 1, 2, 3, 4, 5, 6. 4 times 6 equals what? I could count by sixes to find out. I could use repeated addition to find out. I can use a combination of both. So I have like 6, and 6 here makes 12. And I know I have another set here, and that also makes 12. And 12 plus 12 is 24. Now, they didn't ask us to solve it. I went ahead and solved it just to be a little extra. But number 3 and 4 just wanted you to write a multiplication equation. They didn't say solve it. Let's look down here at your independent practice that you are going to be doing today. It says fill in the blanks to show addition, skip counting, and multiplication for each array. I will check this when you come to school. Some of you on Thursday and Friday, and some of you I will see Monday and Tuesday, and some of you I will see you eventually. So I will be checking your math books. You need to do your independent practice. And also, this is independent practice. Practice makes perfect. So I know when we have a test on this, if you don't do so hot, you probably were not practicing, okay? So you do this for you. Okay, you are your own advocate, your best advocate. So make sure you're doing your work. Now, you have to do number 5, 6, 7, and 8, and 9. And what you have to do in here, you have to fill in the blanks to show the repeated addition sentence. You'll also have to fill in the blanks to show skip counting. So skip counting, you could use, think about that number line, okay, as a visual. But also you could just look at your array. You say you start with 6. 6 more would be what? 12. And then 6 more after that would be 18. So use the repeated addition to help you fill out the skip counting. Remember, skip counting is every other 6. So you start with 6, add 6 more, and then add another 6. You have 3 groups of 6 here. I just gave you a hint for the next problem, which you have to write a multiplication equation for this array. Your first factor is already there. That tells you how many rows you have. 1, 2, 3. You need to just fill in that second factor, which tells you how many's in each row. Count your columns, okay? You have to do that with 6 and 7, and then down here for set 8 and 9, it says draw an array to show each equation. Write the product. Product is the answer to a multiplication equation. So you have to do your best and use circles to draw 5 rows of 6 and 2 rows of 9. And then you could either choose to use repeated addition to solve for that product or skip counting. It's up to you. And that is your independent practice today. Before I let you go, we're going to watch this video together. And it's going to have us take another look before we leave and get started on our assignment. Let me pull it up right here. Had it right here. Nope, that's not it. All right, here we go.
Today we're going to talk about using arrays to solve multiplication problems. What do you notice about this picture? Each row has the same number of circles, and each column has the same number of circles. When you have objects sorted in this way, it's called an array. Multiplication problems use equal groups, so arrays can help us solve them. Let's take a closer look. You picked a bunch of apples from an apple tree, and now you want to arrange them in an array to figure out how many you have. You put them into 3 rows, and you put 5 apples into each of those rows. Now we have an array. We can use addition and multiplication to figure out how many apples we have. Let's start with addition. We have 3 rows of 5 each. We can write that addition problem like this. 5 plus 5 plus 5 equals 15. This is also a multiplication problem to show that we have.
Now, remember, whenever we see repeated addition, that is also telling us that we can make that a multiplication equation or problem. And I want you to take a big look here. Number of rows, 1, 2, 3. 3 rows of 5. There are 5 apples in each row. Look down here. 3 5s represent those 3 rows of 5. Now, pay attention. He's going to show us how to do it with multiplication.
3 groups of 5. We can write 3 times 5, and that will also equal 15. To check, you can count up the apples to make sure it equals 15. Multiplication just means that you are working with equal groups. As we saw, arrays are always made of equal groups, which makes them a great tool for solving multiplication problems. Go ahead and draw some arrays with whatever shape you'd like. Then practice writing out the repeated addition and multiplication problems that go with them.
All right, so we're going to do some of those in our math book. So remember, you have to do pages 5, 6, 7, 8, and 9 for independent work today. And then you need to complete your exit ticket.